Hello, welcome back. We're going to continue our discussion of vectors. In this example, this is a calculator question, and it tells us that a particle is moving along a curve in the xy plane and has the following position, x of t, y of t. Again, these are going to be given as parametrics in terms of t, where x and y can act independently from each other. And we like to use parametric with vectors because remember, a vector, a parametric and a vector, they give us position, and if we graph a parametric over time, we can get direction. So you always typically see vectors written as a parametric function. Now they give us the position, x of t, as is 2t plus sine t, and the y position as t squared plus 2 cosine t, where t is somewhere between 0 and 10. So they are restricting the domain. That's really nice, since these are Trigalicious functions. It might be nice when they restrict the domain. Then they say find the velocity vector at the time when the particle's vertical position is y equals 7. So let's deal with the velocity vector first. So we know to get the velocity vector, we are going to we need the derivative of our position vector. So it's going to be x prime of t, y prime of t. Now this is a calculator question. We don't actually physically have to take the derivative here. We'll talk about that in just a moment. But if you did want to, you don't have to do this. Don't need this. The derivative for my velocity vector would be 2 plus 3 cosine t, and then 2t minus 2 sine t. Now, I'm not a big fan on a calculator question doing things like this, mainly because you might get it wrong, or the derivative might just be too hard or too complex, and you don't get points for it anyways. But if you wanted to do it, you can have that, and that's fine to use. All right, but this is our equation that we're using, x prime of t, y prime of t. What we need in either case is t. So how do we get t? Well, that's what the next part they says. They say the particle's vertical position is 7. So they're saying y of t is 7. At some time t, the y value is 7. And I can just plug that in. T squared plus 2 cosine t equals 7. And now you know why this is a calculator question. You cannot solve this by hand. Don't try it. Use a calculator. And I'm going to use my TI Nspire. One day they may give me a sponsorship. So I'm going to start to see. Now I tend to like to use these as a graph. So I'm going to graph it. And my one is going to be, now I don't use t. I'm going to use x. Kind of hard to see there. Maybe if I can make it a little bit brighter. That doesn't really help much. Hold on here. Whoops. Let's see if this might help. That helps a little bit. There we go. So I'm going to go x squared plus 2 cosine x. Don't use t. I am in function notation on my calculator. So I'm going to use x. Press enter, and there it is. And I want to let it be 7 as well. So tab at 7, and I want to find out where they intersect. And I can see where they meet. I can find that by using my menu, Analyze Graph, and I'm looking for that intersection. And I'm just going to scroll here. I'm not worried about below, before, just after. And when they meet up, I get this point 3, 7. Now, most likely that's probably a decimal, so I'm going to hold over here. Okay. Press enter. Hold on here. Enter. If I hold over this, and I think if I press enter, shoot, student told me that a while back ago and I forgot the trick to it already. Alright, I'm just going to go. Anyways, what you should get is t equals 2.996. And the reason why that's important, the AP may not accept rounding. So my calculator is rounding kind of weird right now, but you would get 2.966. And once we have that, now I can get my velocity vector. V of 2.996. Now again, I'm going to use my calculator for this, but I'm going to go to the home screen, homies. And let me clear this all out. So there's my equations, and I'm going to look for their derivatives. And I could use this. Go Menu, Calculus, and I'm looking at the derivative at a point. I can use t or x. I'll just keep it with x. At 2, delete, press Enter. Press 2.996. I'm looking at the first derivative because I want velocity. If I want acceleration, I can change that to, I can change this to second derivative, but I want velocity. So escape. I just press Enter, and then I type in my function. 2x, I'm using x, plus 3 sine of x. Press Enter, and it gives me negative 0.968. I'm using my chevrons, and I'm going to do the same thing with the y. So I'm going to do y of that. So do the same thing with the y's. Menu, 4, 2, use x still. Ready? Still 2.996. Enter, and I just type in the function. Using x again, x squared plus 2 cosine x. Press Enter, and we get 5.704. And that's all you need to show on your work right there. Now, if you use this equation, you would just plug the 2.966 into those t's, and you get the same answer. All right. So I hope you enjoyed this video. Go on to the next one, and we'll do one more example with you guys.